Water is our most precious foodstuff. We expect it to be available at all times in sufficient quantities and top quality. Our water resources must be treated with care, and that means extensive analyses and checks are indispensable, and these are therefore anchored in legislation. Water analysis. Summation parameters. The CSB or COR method. CSB is the German abbreviation for Chemical Oxygen Requirement, COR. The COR test is used to establish the degree of contamination in bodies of water and effluents, in particular those containing organic pollutants. It determines how much of an oxidizing agent, potassium dichromate, the water sample takes up. The reaction is carried out in an acidic solution in the presence of silver sulfate. To carry out a COR test, we need a precision heating appliance, appropriate boiling aids, reaction vessels, pipettes, dispensers and a titration apparatus. The reagents should be of analytical purity. The relevant DIN standard stipulates that the dilution water used must be of the purest quality. COR determination can be carried out manually or, as shown in this film, largely automatically. To confirm the reliability of the results, a reference sample and blank samples should also be examined. In place of the analysis sample, water is used for the blank value. For the reference value, we recommend potassium hydrogen phthalate solution, which has a chemical oxygen requirement of 200 milligrams per litre. The analysis samples are pipetted into reaction vessels. If the analysis samples have a chloride ion content of greater than 1 gram per litre, this must be dissipated by means of an HCl absorber. A rotation device can be used to speed up this procedure. The reaction vessels with the prepared samples are now placed in a cooling bath. Under constant mixing, 10 millilitres of potassium dichromate solution containing mercuric sulfate and 30 millilitres of silver sulfate sulfuric acid are added. To avoid overheating and to prevent, as far as possible, the loss of volatile substances, the sulfuric acid should be dispensed in small doses in a cooling bath. The use of a circulation cooler helps to save water. After adding the boiling beads, the cooler funnels are fitted. After wiping off any water adhering to the bottom of the reaction vessels, they are carefully placed in the heating appliance. The reaction mixture must be heated to 148 degrees Celsius within 10 minutes, and then allowed to gently simmer for a further 110 minutes with a tolerance of ±3 degrees. After the reaction mixture has cooled down to below a temperature of about 60 degrees, the cooler funnel is flushed with water. The contents of the reaction vessel are diluted with high purity water to at least 100 millilitres and allowed to cool to room temperature. Special collars, together with the vessel rack, allow 12 reaction vessels to be determined simultaneously. Evaluation can now be carried out. In the film, we're using an automatic titration apparatus. The relevant DIN standard parameters are entered. Any potassium dichromate still present is titrated with ammonium ferrobisulfate. In each series of tests, 3 blank samples and 1 reference solution are analysed in the same way. A workstation such as the one shown in this film considerably simplifies COR determination. Once placed in the rack, the reaction vessels remain there in the same position throughout the various steps of the process. The results. The titrated solutions are collected and diluted with water. The silver and mercury compounds they contain are removed with the Berosorb. This process is specified in the German DIN standard 38409 part H41. In summary, it can be said that COR parameter analysis has the advantage that it's simple and easy to carry out in practice. The process provides valuable information on the presence and quantity of organic substances, especially as a criterion for water pollution. Further films on the subject of water analysis will follow in this series.